Somebody's got a tough job. After lunch, Haydn, you gotta keep everybody awake, mate. We gotta get everybody exercising. Okay, so without further ado, Haydn Andrews, everybody.
Hey guys, can you hear me? Beautiful, it's working. So I'm Haydn, going to be doing a presentation on warehouse wireless design. So just quickly start off with what not to do in a warehouse. If technology works. So obviously this guy's having a bad day, and I would not want to be the guy going to his boss and saying, I just broke the entire warehouse. Apparently the guy survived. That's me on Twitter at the WN and blog at wn.com.au. So what are we going to cover? Going to cover what is a warehouse, safety in the warehouse, designing wireless for the warehouse, and if there's time, some troubleshooting in the warehouse. So what is a warehouse? There's a couple of different dictionary descriptions of a warehouse, but the best definition, it's a large environment that presents a Wi-Fi design challenge that can be met by well-equipped and well-trained WLAN professionals. I do like the dictionary definition of number 4, because after being in a warehouse quite a bit, sometimes it does feel like a mental asylum. So what type of warehouses have we got? We've got distribution centres. So distribution centres are generally, like your retailer, they get all their stock into that distribution centre and then they ship that out to their stores. Production centres and factories being places that build things, conveyor belts, automobile industry, not that there's much of that left in Australia. Retail, whether that be their distribution centre or whether that be just a little warehouse out the back of their actual store where they store their stock before it goes out to the store, to the shop floor. We're going to have cold storage. Now cold storage can be 2 degrees, 5 degrees, negative 27 degrees, and that presents some challenges as well. We're going to have fresh produce, and along with fresh produce we can have things like meat and other types of food products in the warehouse, which can have some challenges around actually working in that environment, but also challenges around how do you actually install the wireless without affecting operations to those conveyor belts, because some of these places can run 24/7. And then there's pretty much a whole bunch of other little different types of warehouses that we can come across. So safety is one of the big safety. So first of all, what not to do. I would love to do this. It would be a bit of fun, but I'm pretty sure you get sent off site pretty quick. So safety rules in the warehouse are critical. If you don't follow the safety rules of the warehouse, yourself as the wireless LAN professional and your company can be forcibly removed from site and may not be able to get another contract back in that warehouse. The safety SLAs in most warehouses apply to anyone that's in the warehouse, so it affects the stats of the actual people working in there. You may need to undertake some site inductions to that warehouse. Now that may be specific to the company, it may be specific to the site, and it also may require some additional certification like white card type courses to be done. You may need to be escorted in the warehouse. Some of these warehouses won't let you just wander around aimlessly through the warehouse looking at where I can mount access points, what's the wireless coverage in this warehouse actually like. So you may need a person from the site to escort you around, or it may be that the site will allow you to have another person that walks with you to make sure that you don't get run over by a forklift while you're busy looking at your iPad. Personal protective equipment. So most warehouses will have some kind of personal protective equipment requirements that you need. So it may be eye protection, safety glasses, hearing protection. So obviously the factory type and production type facilities are going to be quite loud, noisy, potential of things that can get you in the eyes, so you may need to wear eye protection, hearing protection. You may need to wear hard hats, particularly if you're going into a warehouse when it's still under construction. Pretty much every warehouse I've been into, you've had to wear safety shoes of some kind. Normally steel cap, pretty much all the time been steel cap. You may need to wear high vis or reflective type vests, shirts, pants, something so you stand out so the forklift operators or the people working in there can see you. There may be specific types of clothing requirements. So you've got the photo of me in a meat packing plant sitting in the server room. Server room, you had to walk all the way through the actual production floor of the place. So you had to comply to having overall pants, basically a lab coat, hair netting, beard netting, to walk through there, and then you had to scrub in and scrub out like you were going through a hospital. And you possibly, more than likely, will have to have some sort of identification. Now that might be identification to physically get you on site with the security gatehouse, but it might also be you've got to walk around with a badge or something to identify you while you're on site. Quite often, with pretty much 99% of the time in warehouses, the roofs aren't like this. I can't just get a 2.4, 2.7, 3.2 metre ladder and stand on it and install an access point. Getting an AP on a stick up to some of these roof heights can be 8, 10, 12, 27 metres high. So getting access points up to where you want to mount them is generally not easy to do with a tripod. And if you do have a tripod that will work, you might have some, might not be allowed to use it in the warehouse. So you might need an elevated work platform. Generally in Australia, to use the elevated work platform, you're going to need some sort of licence or certification course to be conducted. What you might be able to do is you might be able to get an operator at the site to take you up in the elevated platform. But you'll probably more than likely need safety harnesses for working at the heights. You may need the working at heights. Quite often you might use your electrical contractors or the local site maintenance guy to actually take you up in that ELP if they'll let you. All right, so let's get into designing for a warehouse. Okay, so a warehouse has lots of different coverage requirements and challenges that you're going to have to look at. So we're going to be looking at using different types of antennas. In pretty much every warehouse I've been into, I've found some sort of non-Wi-Fi interferer. Anything from PA systems, Bluetooth, what else we had? 4G repeaters, so these home-style 4G Telstra repeaters where you stick one in your window so it can talk to the 4G out in the outside, and then they stick one further in the building, normally meant to be just in a house to help you out at home. I've seen them wipe out the entire 5 gig band pretty much, using an 80 meg up and an 80 meg down channel on them, and pretty much just been 100% utilised. Most warehouses, we're going to have large amounts of metal, which is we're going to have reflection and multipath challenges to overcome. We're also more than likely going to have some sort of floor plan accuracy problems. Quite often you'll find you can get all the walls, nice and thing, the racking, the conveyor belts, whatever they've put in that warehouse. They may have decided to change them around. They haven't gone back and got architectural plans redone. So we've got to make sure that the floor plans are as accurate as possible, or work out how we can actually update those floor plans to allow us to do the design. Particularly in a distribution centre, one of the challenges is also stock levels. So this time of the year, it's Christmas, a lot of distribution centres are full to the brim. They're getting all the stock in there to ship out to their stores to allow you to buy all the kids' and latest gadgets and toys. So they're like full to the brim of stock. Come a couple of months when it's a slower period for retail, they might have hardly any stock in the racks. So obviously we've got changing attenuation areas in the warehouse. So we've got the racking. One day it might be 8, 12, 24 dB drop. Next day it might only be 4. So in the design we go through some preliminary work. So like any normal wireless design, one of the first things that we do is we ask the basic questions. What type of devices are you using in the warehouse? What are the business requirements for the wireless design that you're putting into the warehouse? Where do you actually want coverage? The warehouse might say, we want coverage out on the actual floor, or it might be you just putting wireless coverage in for the actual office spaces, and maybe there's a couple of different little areas that they want coverage. So where is the coverage? Is it inside the warehouse? Is it outside the warehouse? What are the business requirements to use that coverage? So are they planning on mounting some sort of device to movable vehicles? Are they tracking stock moving around on conveyor belts with RF tags? We need to understand that to formulate our design. One of the things that I find quite useful is once I get those floor plans and we've worked through whether they're accurate or not, is effectively give them a highlighter, colouring where you want coverage, and define what you want the coverage to be for in those areas. We quite often, you have to organise the site survey at the site. So a lot of these sites, you can't just rock up on the door, knock on the door and walk in, I'm here to do a wireless survey. It needs to be pre-arranged. Sometimes a bit more than just your carpeted office type of environment. It may be that the head office of the company has engaged you to go do that wireless design, but the actual warehouse doesn't have a clue who you are, what you're there to do. So you've got to make sure that you've sorted that out with them. You also don't want to walk up to that site without that personal protective equipment or any other site access requirements to the site, because you might get to that gatehouse, you haven't got steel cap shoes, you didn't bother to ask whether you needed them, sorry, not coming in. So make sure that you check out what personal protective equipment you need to bring, but also it may be, as in the case with a lot of the food plants, it may be you just need to bring your steel cap shoes, we provide the rest of the gear for you, but it might be, well, I'm 8 foot tall, 5 metres wide, am I going to fit into your provided clothes? So things like that you've got to keep in mind. How will the users be using the wireless in the different areas of the warehouse? So are they vehicle mounted devices? Are they physically walking around? Are they sitting at a desk and not moving? Along with how they'll be using it, where they'll be using it. So are they, particularly in racking type areas, are they wanting to have like a little alcove that's been cut into one of the racks where they'd normally store a couple of pallets, where they want to be able to sit down at a desk underneath that? Do they need coverage in there, or do they just need it in the actual aisle? And of course, as been spoken about quite often today, finding out what that least capable, most significant device is. Now, in a warehouse, generally, it will be the least capable device will be the most significant device. I think I stole this from Francois' presentation at maybe WLPC. Warehouses are like snowflakes. They're all different in their own way. Effectively, no warehouse is the same. You can go into a warehouse for the same company at two different sites doing the exact same job, and you'll find differences in the warehouse, whether that be physical floor layout, whether that be devices, whether it be how they actually use the wireless in there. So don't do a warehouse design without at least going to site once. We'll just talk quickly a little bit about some of the client devices. So warehouses don't generally have your typical client devices that you see in carpeted offices. You will definitely see laptops in there for their corporate type use in their office spaces. You'll definitely might see some iPads, some Apple devices, handheld phones type of thing in the warehouse, but they're not the critical systems generally in a warehouse. The critical systems in the warehouse are there, if I can make this lazy thingy work, are their hand scanners. So effectively it's a barcode scanner with a keyboard that anyone that's got decent sized fingers can't actually type on them because they're tiny little things. Quite often you'll find that they're WEP or TKIP, 2.4 only type devices, may have been end of life 20 years before I was born, type of thing. Next thing you know, we've got like vehicle mounted units. So effectively these are effectively a laptop, touchscreen, but hardened for the environment that they're working in. So they're built to put up with the rough using that the operators are going to give them. Some of these operators will, it's not like I'll just tap the screen, it's I'll punch the screen. They're also hardened to survive in areas like refrigerators and freezers where the temperature can get quite low, and also in some of those tropical areas where some of these warehouses, it may get 30, 40, 50 degrees Celsius in those warehouses. And then we've got quite often something like this, a Vocalec type device. Now these devices are effectively This part of the device is the actual computer device. It's got no user interface, so you've got that challenge of if you do need to have to try and configure it, you've got no physical user interface. You quite often have to go to the device vendor or the device supplier or whoever's looking after the device to get into those devices if anything needs to be reconfigured on them or looked at. Effectively, this device talks to the wireless, and then it uses a Bluetooth connection to a headset, and the operator basically talks to it as the user interface. So that's obviously adds a whole bunch of Bluetooth devices that are now operating in a warehouse. Quite often, so the application that most of these devices will use will be some sort of warehouse management system. It's generally a low bandwidth application, effectively a telnet session to a server. All it's really doing is sending a barcode or a product code back to the server or collecting what the actual product that the people need to actually use or actually physically grab off the shelf, put on a pallet to get shipped to the store. So they are a low bandwidth application and effectively a telnet session. Quite often in the warehouse we'll see more APs than clients. And we definitely notice, and I've definitely noticed that because of the amount of legacy devices that you have in the warehouse, coupled with things like the Bluetooth that they run on, the legacy data rates that they require, potentially not supporting any of the KVNR type roaming enhancements, not supporting decent data rates, requiring very low data rates, and their security encryptions, they can make an impact on the wireless network overall. Not all devices are created equal, so this came up before. This is two devices sitting side by side. We've got one at a neg 68 dBm and the one right next to it, neg 53. So it goes back to that designing for the least capable, most significant device. You need to work out what they are. Now, with your laptops and that, you can go to sites like RSSI Compare and determine what your offset will be from the Ecohouse iKick when you're doing the survey. With a lot of the warehouse devices, you're not going to find them on a nice site like RSSI Compare potentially, so you'll have to go investigate this yourself. So when designing the warehouse, there's a couple of different schools of thought and different methodologies that you can use for the different antennas that you can use in the warehouse. So we can look at using overhead omnis, generally with an external type antenna. Now the pros of using these are you can deploy it rather fast. It's slapped up on the roof, it punches large coverage cells out, and that's traditionally how a lot of warehouses were designed back in the day. Problem is, very susceptible to stock levels changing. Stock levels change, you're not pushing the coverage down the aisle, you're relying on APs that are just bleeding coverage straight down through racking, through stock. And then, whilst the pro could be that large coverage area, it could also be your con. One of your cons of using them. I've seen devices 200, 300, 400 metres from the access point refusing to roam because it's still seeing it at neg 72. The other con is, generally these things sit above the actual racking. Obviously the signal's going out, they're all above the racking, and if you're not using static power, those devices can see each other really well, and your controller tunes them way down, and all of a sudden your cell size that you thought you had is about a third of the size. We can use end of aisle. So this is using a directional antenna of some kind, effectively mounting it. So I have an aisle going down that way, effectively mounting it up here on the wall or on some sort of mezzanine level railing, pointing down the aisle. It could also be that I drop the AP and antenna down from the ceiling to mount it because I can't mount it on a wall. Now this gives you some really good line of sight from the client to the AP. It's effectively pushing the signal straight down that aisle to where your client's actually going to be. So you're going to get some increased signal strength. One of the cons, and I've seen this before, particularly when you mount them on the wall, is the wall was nice and clean, nothing there this week. The warehouse manager goes, I need more racking for more stock. He goes and whacks a row of racking roll on that wall. Your AP's on the wall, stock sits right in front of it, and there goes your signal. We can look at mounting the APs overhead, so in the actual aisle, pointing down at the ground. Now this actual AP that antenna that propagations, I can't remember what it's called, but it's Eddie's Wi-Fi axe, is how he called it. Effectively, it's got, I think it's 120 degree one way and about 15 degree the other way on the beam width. Obviously, one of the cons is you're going to end up with potentially a lot more APs, particularly if they want multiple coverage in that single aisle, or depending on how many aisles that you've actually got and how long those aisles are and whether it actually pushes through it. But you're going to get some really good SNR and you're going to get some really good signal level through those things. It's also, because it's above the actual racking and above any place that someone can mount a new rack, one of your best things is it's not going to get obscured. The only real risk is old matey with the forklift whacks his forklift up and wipes out the antenna. So you've got to make sure that when you're mounting any of these antennas, that they're mounted, and APs, that they're mounted in a way that it's not going to obstruct operation of that warehouse. And look at things like, instead of using a fixed pole to mount the AP down from the roof, look at things like suspended cabling with some sort of board. So if it does get a little bit of a hit, it's got a bit of give and take and it doesn't just snap off the roof. Other considerations when we're looking at the access point. So we've got a couple of different things. So we've got enclosures for the APs, so NEMA enclosures to put the APs in. Particularly if the APs are being mounted in areas with high dust, potential water content, high humidity type environments, or if you're using an AP that's an indoor AP but you're physically mounting it somewhere it could be exposed to the elements, you want to protect the AP so it doesn't get full of water or full of too much dirt. If you're looking at a fridge or a freezer, potentially the environmental of that room is going to be colder than what the actual AP manufacturer's specs say that it can operate. So sticking an AP in a freezer at negative 27 degrees of a particular model, if you log a TAC case, if they find out that it's in a negative 27 degree room, they might say, well, it's outside the data spec, we're not going to help you. So what we can do is you can mount the AP in the mezzanine floor and then put the antenna in the actual cold environment. And I've covered off on liquids on those things. So I use the predictive survey predominantly to do a lot of the warehouses of environments where I've worked in that environment before. The things that we've got to make sure are what are the heights of our actual racking in the warehouse, and what's the attenuation average that we're getting through those racking? Are the racking placements actually correct? And what height can we mount those antennas? So all the things of making sure that we get the information that we're into the predictive of what we're actually going to put out on the floor. The sensitivity analysis is a big one, making sure that we're designing for that least capable device. One thing I've found doing an AP on a stick survey out here in Australia sometimes can be very hard to get over the line. Obviously it costs a lot more, takes a lot more time to physically go out and mount an access point and take readings at every area. You may have to close aisles, close operations down, or it may need to be conducted after hours. But it is very useful in places where it's where you haven't experienced it or you don't know what it's going to be in that environment. So high ceilings, very narrow aisles. Like I've seen places where the aisles are effectively the same width that you get in a library where you can't get down it without banging your elbows into it. There may be mezzanine floors, like Dev's presentation. You want to see what the propagation through those mezzanine floors are. There may be machinery or machinery operating in that environment that you want to see what's going to happen when that machinery actually is operating in that environment to your actual wires. Not only from a spectrum point of view, but it could be something's moving up and down, and every time it moves down, you lose a heap of attenuation from that device or end up with a bit of reflection that you don't want. And of course, any unknowns. So if the fridge freezes, you could have no idea what those wall attenuations are actually physically going to be without taking some measurements. So I break the warehouse down into a few different areas. We've got racking or high bay areas, conveyor belt type areas, open areas, which are quite often like your receiving dispatch areas, mezzanine, and then you potentially have office spaces that may be inside the actual warehouse or maybe outside the warehouse. So I look at each of the areas and work out what's going to be the best design with the different antennas and different placements that I can get into those areas. Some of the other considerations that we can look at, do we use auto channel assignment and auto power assignment, or do we set everything static? Do we use DFS? Now this can be really important, particularly around the channels and DFS. So are we actually, as Keith said, are we actually having DFS events in the place? But do the clients actually support the channels in the DFS range? Quite often, a lot of the devices won't support them. Are the devices actually roaming, or are they static? And as Keith said, working out when they actually roam and what their game, what do you call it, Keith? The green diamond, what it's actually operating on to when it's going to roam. Looking at what our, but effectively, what are we actually looking to design for? We also then need to look at things that are coming into warehouses these days. IoT is starting to become a big one. Temperature sensors, location tracking type tags, humidity sensors. I want to fly drones through the warehouse to see what stock's in the warehouse. Lots of different things coming around. There's potential robots coming into the warehouse, whether that be physically taking stuff off shelves and moving actual pallets around that you see in some of those Alibaba and Amazon type videos, or automated guided vehicles, which are effectively these big red things that pick up a pallet and self-drive themselves around the warehouse and drop it off somewhere else. So we need to work out what's coming and when it's coming to make sure that we get it into the design. Now I'm just going to quickly go through some troubleshooting, because we obviously had Keith's great presentation on wireless troubleshooting, so pretty much everything Keith said, but there's a couple of things that I've seen quite often in warehouses. So coverage holes. Now most of the coverage holes that I've seen in the warehouse have been from old legacy designs. The site's changed how they operate, they've changed the stock levels, they've changed where they store the cans of baked beans versus where they store the bags of cement, and that's changed the propagation in the warehouse because no one's looked at it since it was commissioned 10 years or so ago. Wireless drivers and the client issues, making sure that we're looking at whether it's a client issue or whether it's an actual wireless issue. Roaming issues, quite often with some of these clients, if you've got large cells, they can, particularly in the open areas, they can be seen and stay on an AP that you don't want it to stay on. One of the things that I didn't think we'd see, this is courtesy of Jurgens from a site in South Africa. It doesn't come up very well on this. This is effectively a meerkat that's decided to pick up a cable and start eating the cable. So rodents can be a problem in warehouses. Yeah, oh, monkey, sorry. And then obviously the upstream services can cause us lots of problems. Application, DHCP, DNS, but everything's always a wireless issue. And I've got a couple of minutes to spare, and thanks guys. And if I got to design a warehouse of my choosing, I think I'd like to have a crack at this place. It's the Boeing factory. I can't remember where it is, Keith will know. And I believe when they first built it, it had its own cloud system or own environment turn up in the building, and it's the largest building with single span roof. So it'd be a bit of fun with working out what attenuation of a Boeing 787 is. Thanks guys, I'll let these next guys crack on because they've got a really interesting topic.
All right. Thank you, Haydn. So can you believe we've got the last talk for the day? On time. And on time. So this is like a WWE style, combined powers type of presentation. So we've got Stephen from MIST, and we've got Francois from SemFio Networks. Hope I'm saying that correctly. I think take it away, guys.
Awesome, thank you. We'll just get this set up so we can actually show you what we want to show you.
It's a multi-continent of business. Alright. Let's see what with my finger.
All right, how's everyone doing? You ready for the Wi-Fi 6 Power Hour? Yeah, cool. We've got to keep you entertained. So this is going to be a technical deep dive for the first 30 minutes. Then I'm going to hand it over to Francois, and he's going to talk about design considerations for Wi-Fi 6. So let's kick it off. This is what we're going to be covering in a very short space of time, so bear with me. The great thing is we have some awesome networking happening after this event, so feel free to come and ask questions. You can reach me on Twitter as well. My Twitter handle's up there. And you actually get a copy of all these slides as well. I don't know if Grant mentioned that earlier today, but you'll have these as reference slides too. So I actually threw up a little Twitter poll last week just to sort of get a taste of the environment for what the Wi-Fi community says. Hands up who's not on Twitter. Get on Twitter, because then you can engage with us more often. So I ran this little Twitter poll saying, okay, what do you think is going to be the most important technology for 2020? Most people said Wi-Fi 6. There's some other cool stuff happening there. I reckon by the end of 2020, people's feelings about this might change. Wi-Fi 6 may no longer be the new thing or the cool thing. It might be commonplace, but we'll see how we go. So just a bit of background as to why it's called Wi-Fi 6. So we've got the IEEE, who helps develop the standards for both Wi-Fi and wired networks. But we've got the Wi-Fi Alliance that actually does the certification of access points and radios and interoperability with end devices. They decided to brand Wi-Fi 6 as the 6th generation of Wi-Fi because most consumers and users out there are used to 3G, 4G, 5G, iPhone 6, 7, 8, that sort of stuff. So that's where it came from. So where we're at today is the 802.11ax ratification or draft for version 5 has just been passed, and into late next year, the actual IEEE finalisation is supposed to happen for 802.11ax, but there might be some changes that are happening in there, which I'll talk a little bit about. So Wi-Fi 4, 802.11n. Previous generations of Wi-Fi were all about getting greater bandwidths and greater speeds. So yeah, anyone who knows this car, Bugatti Veyron, very, very fast car, 300 miles per hour. Okay, well, so Wi-Fi 5, 802.11ac, more bandwidth, more speed, faster. Anyone knows what the other car is? It looks very similar. Mostly the same, but it's another Bugatti Chiron. So it can go faster again, but nothing else has really changed. You can only really fit 1 or 2 people in these cars and transport them at very high speeds. So what do you really want to do? You want the rocket bus. Wi-Fi 6 is the rocket bus. You can get multiple people all at the same time going really fast as well, very efficiently. That's what Wi-Fi 6 is about, the rocket bus. So this is a good reference table just to go, okay, well, what's changed? Wi-Fi 5, 802.11ac was 5 gigahertz only. We introduced the 160 megahertz wide channel, which is probably the worst idea in the world, but it was there. We had some other enhancements such as multi-user MIMO come in, but multi-user MIMO wasn't very widely adopted from the client side of things and wasn't very optimized from the access point vendor side of things too. But now we actually see Wi-Fi 6 is both 2.4 and 5 gigahertz, which is kind of cool. A lot of people are scared. 2.4 is the junk band, but it has to be treated fairly, just like the 5 gigahertz band is. So a lot of IoT devices and other telemetry devices operating at 2.4 can actually take benefits of what we'll be talking through in the next 25 minutes. Multi-user MIMO is actually being more forcibly adopted as well. Part of the Wi-Fi Alliance certification for Wi-Fi 6 mandates that devices support multi-user MIMO. So it's no longer an optional extra to have. So that's actually going to see some interesting adoption in the landscape too. So really, just to reiterate the point, it was all about speeds and feeds before. Now it's all about over-the-air efficiency and getting devices, multiple devices on and off the air quicker than they have ever before. Because really, Wi-Fi has a scale problem. The more clients you get on Wi-Fi radios today, the higher your latency is, the less the throughput that you can get aggregate on an access point radio. You get sort of beyond 30 to 50 devices all trying to communicate on AC or 802.11n, and you really hit that limit very quickly. So Wi-Fi 6 is going to change that. Think of your high-density deployments, stadiums, even conference centers like we have here, even warehouse devices where they're going to have multiple different devices talking on both 2.4 and 5 gigahertz. There's going to be a lot less contention over there thanks to Wi-Fi 6. Because this is what we've had. On the left-hand side, everyone's been just sort of honking the horn at each other, struggling to get through the roundabout. Thank you. Perfect timing. Could not ask for better timing than that. Well done. Thanks, Philippe. I'll give you the $50 that I gave you to do that at the right time. No. So really, we were trying to get people through the roundabout and get the traffic flowing faster without any hold-ups at all, without people having accidents or reducing the collisions over the air. So This is another good analogy. You've probably seen this a few times before if you've seen the National Instruments document or white paper on Wi-Fi 6, just talking about, okay, if you've got a FedEx truck and you're ordering a smart TV from Amazon, Wi-Fi 5 would be like just that single FedEx truck shipping your single smart TV to only you, and the rest of that space in the back of the FedEx truck is wasted. Whereas Wi-Fi 6 is more like having everyone's Amazon smart orders for your suburb, smart TVs, fridges, dishwashers, all that sort of stuff, jam-packed to maximize the space in that FedEx truck. And then you can talk about multiple spatial streams being multiple trucks driving down the same highway at the same time, that sort of thing. So it's a kind of cool analogy. So what did we get with Wi-Fi 6? OFDMA. OFDMA is the big game changer, and it's what I'm going to spend most of the time talking about. We've changed the subcarrier width. We've divided that by 4. We've multiplied then the number of subcarriers that we can have by 4. And the symbol duration has also been multiplied by 4. So that gives us some more resiliency, gives us more robustness when we're trying to get these higher data rates and have these multi-user operations with OFDMA. We want some more resiliency there. Plus, in 2.4 and 5 gigahertz, longer symbol durations and guard intervals, which we'll also talk about, are really beneficial for outdoor links. So another analogy to look at this is Wi-Fi 5 had a lot of unused airtime. So any time a Wi-Fi 5 or a Wi-Fi 4 device had to contend for the medium, they would block off that full 20 or 40 or 80 megahertz channel, whatever they contended for the medium for. That channel at that space and time was theirs. But they barely even scratched the surface of what they needed to use from that channel. Most traffic over the air is about 300 bytes or less. So what did we have? We had a lot of missing, unused white space that was reserved for a single device, which is very, very wasteful. So what does Wi-Fi 6 give us? Multiple devices, multiple users of different traffic types, different payload size, different quality of service markings, fully jam-packing those channels as much as they can. Much more efficient use of that space. You don't see any white space in there, so that's the aim of the game, is to really increase the efficiency of how the medium is used. How do we get there? So those little blocks that you saw there are actually breaking up these multiple subcarriers that we now have with OFDMA into what's called subchannels. Some people call them baby channels. They're actually called resource units. So we have resource units which can be down to 2 megahertz small, which is actually quite useful. So with the 20 megahertz wide channel, you can actually have up to 9 users in 2 megahertz wide resource units. The cool thing to know about this, 2 megahertz is actually pretty good for about 375 kilobits per second throughput. Now, if you're thinking about IoT and telemetry devices, even healthcare devices, not a lot of the bandwidth is required for those to actually communicate on the network. So we can save a lot of overhead from just having resource units allocated to those low bandwidth applications, and they don't have to reserve those 20 or 40 megahertz wide channels anymore. They can free it up, and you can have other blocks of resource units coexist at the same time for, you might have an iPad streaming video, or you might be doing some voice over IP sort of stuff. So that's really cool. Good point to note here, minimum RU size for multi-user MIMO operations is 106. As we go through 40 and 80 and 160 megahertz channels, this sort of just scales out a bit more. So there's some other things that I'm not showing here, like pilot subcarriers and guard bands in there, but this is essentially the resource units that can be used for data communications. Now when we break this in, this is just a nice little reference table. So if you want to slice and dice what your different channel sizes are and go, okay, well, effectively, how many users could I actually get sliced up in there? I've sort of highlighted what I expect is what we will see as the norm, because not many people are deploying any wider than 40 megahertz wide in enterprise today, especially not in high density environments. I doubt you'd find a warehouse which would have 80 megahertz channels by good design practice. So I reckon what we'll see the mix up being a sort of 2 to 4, maybe 8 blocks of users usefully using 20 and 40 megahertz wide channels over the air with Wi-Fi 6. So note, this is representing Wi-Fi 6 clients. If you've got mixed mode environments with legacy OFDM clients, so Wi-Fi 5 or Wi-Fi 4, it's going to be a different story, right? Basically what people have been saying so far is you've got to have at least 30 to 40% of your devices on a Wi-Fi 6 access point being Wi-Fi 6 capable before you actually see some benefits for those devices. And then there'll be some inherent benefits to legacy devices because your Wi-Fi 6 devices would have gone on and off that channel quicker, hence freeing up some more transmission opportunities for your legacy clients. So that's kind of cool. Good point here. So Wi-Fi 6 certification is only validated for up to 4 RUs. So that means even if you've got a device that supports 160 megahertz wide channels or an access point that supports 160 megahertz wide channels, to get certification, they only have to show that they can operate with up to 4 RUs. They don't have to do the whole 9 for a 20 megahertz wide channel or anything like that. They just have to validate 4 RUs. Little snapshot of what this looks like on the spectrum. So this is taken from an Echo House Sidekick, really good visibility of what we've got here. So this is an OFDM waveform on a 20 megahertz wide channel on channel 44. This is OFDMA operating with 2 clients with 106 RUs allocated to each of them, an iPhone 11 and a Galaxy S10. And just another snapshot there. So what you can actually start seeing here is allocations of resource units, and you can actually see the waveform is actually operating in OFDMA there compared to OFDM. So we'll hopefully show you a little bit more of that a bit later on. So the main operations is the really meaty part of OFDMA and how it's different. So we've got different contention mechanisms, we've got different allocations of the medium that are happening compared to legacy systems. So what actually has to happen is OFDMA clients, Wi-Fi 6 clients, still have to operate at OFDM to have backwards compatibility with the previous generations of Wi-Fi. There's no use these devices all talking Wi-Fi 6 and the legacy devices just not being able to understand them, because then they'll treat it as non-Wi-Fi noise, right? And then that doesn't give the legacy clients a chance to actually get a transmission opportunity. So we actually have a multi-user request to send and clear to send when there's legacy devices in there. And then that way the OFDM clients can understand it. The access point will actually determine what the RU allocation is for a downlink or uplink transmission cycle. So the access point is doing a whole lot of scheduling here on both the uplink and downlink transmission opportunities, and it actually negotiates with all these clients. Okay, send me a buffer status report of what sort of data you have to send to me, what's the QoS priority, what's the bandwidth that you need, what's your expected RSSI, and then the access point will actually negotiate that and send that out to a group of users using trigger frames. And that's where that trigger frame will say, this user here, user 1, is going to get this many RUs. This user 2 is going to get this many RUs, and I'm actually going to transmit to you with 3 spatial streams, not 2. And this user here is actually going to get, another 4 RUs. And it allocates things like that on a dynamic basis. And this happens for both downlink and uplink, which is pretty cool. So looking at one of these trigger frames in Wireshark, we can actually see where users have separate info that's referenced in the trigger frame. And we can see where we get the RU allocation for that particular user. And you can drill down further, you can see, once you actually see the QoS data going across the air, which hopefully will show you, you could actually drill down further and go, okay, well, the DSCP marking for this QoS packet was this, and you can relate that back to going, okay, this is how this access point is actually allocating this bandwidth. And you can actually see, a number of spatial streams as well for this particular transmission. This can all be dynamically variable. So the interesting thing is OFDMA is multi-user by nature. And then we have multi-user MIMO to put over the top. But just because you've got Wi-Fi 6 devices and they can do all those cool things, doesn't mean they always want to be doing multi-user operations. Within a single transmission, you can have a device opt to do single user or the traditional SISO operations that we're always used to. So there's a thing called an operating mode indication, which you can tell the access point saying, no, I don't want to do this, I opt out. So when the access point is requesting for its buffer status report from these clients can say, I had a bad experience last time, Mr. Access Point. I know you tried to give me, some multiple spatial streams and a high MCS rate, but I actually want to opt out of multi-user operations. And so that's where the operating mode indication, the client can choose to opt out of multi-user operations, or the client can then request back to the access point saying, you know what, I'm going to try and just use a single spatial stream this time. So send me what you've got, give me your best shot with a single spatial stream. I didn't have a good experience on 3 spatial streams before. So it's very dynamic, and we've never really seen this sort of interchange between clients and access points before. There's a lot of negotiation, and it's very dynamic. Lastly, there is also uplink OFDMA random access. So where we've got these specific RUs that can be reserved for different clients and different traffic types as well, access points can actually reserve some of those RUs as sort of like a, out of sync, just dynamic uplink. If there's a device that doesn't want to contend with all these other multi-user Wi-Fi 6 devices, it can do unscheduled uplink transmissions just using 1 or 2 specific RUs that the access point is allocated for that. And then OFDMA backoff is what's used for that, because it's not just often a single device that wants to do this. You might have multiple devices that want to contend for uplink random access. So we talked briefly about multi-user MIMO. It's back with Wi-Fi 6. Hopefully we'll see more devices actually use it properly. The big catch with multi-user MIMO, which we've talked about before, is it's really hard to get a lot of improvements with it because you have to be spatially diverse. So if this group of people here, all your devices were multi-user MIMO capable, my access point's going to have a very hard time determining how spatially separate all of your devices are. It's much better if I'm trying to do multi-user MIMO to Francois over there, to Mark over here, and then over on this corner of the room, because that's much more spatial diversity. We can actually do the beamforming and actually direct multi-user spatial streams in those directions. One enhancement that's come to Wi-Fi 6 is we can now group users to try and improve that. So the access point can identify and going, okay, well, you're a group of users in this area. I'm going to try and beamform to all of you with your multi-user OFDMA transmissions that we've scheduled and try and get some success this way. So talking about the truck scenario, think of OFDMA as just this single truck that we packed full of multiple data payloads. Multi-user MIMO is sort of going, okay, well, we want to do multiple trucks. OFDMA is splitting the channel into smaller chunks, whereas multi-user MIMO is actually using multiple spatial streams among different users. I mentioned before, minimum RU 106 to do multi-user MIMO. So that's going to be sort of a minimum requirement, right? So if these devices don't want to use RU 106 because they don't have enough data to send and they don't require a resource unit allocation that big, well, then they're not going to do multi-user MIMO. So this is just a little comparison table that I've done for your reference of my thoughts on where OFDMA will be more beneficial and have some wins for us versus multi-user MIMO. So multi-user MIMO, I reckon it's really going to be useful for outdoor point-to-point and point-to-multipoint bridges. We'll better use the longer guard intervals for greater robustness and resiliency, whereas OFDMA is going to be really beneficial for when we've got high-density Wi-Fi 6 clients. We've got a lot of traffic that's moving very quickly. You've got all these clients trying to communicate at the same time and get them on and off the channel as quickly as possible. Data rates, yes, there are faster data rates, but I mentioned it's not all just about speed, it's about efficiency. But we do have two new MCS rates, MCS 10 and MCS 11, and we have 1024 QAM. Now to get there, we need even higher signal to noise ratio than what we used to. So Francois is going to talk a little bit more about that in design considerations. This is a brilliant table that Francois has put together. If you haven't seen it, I highly recommend going there because he's not only done an MCS table for all of our typical rates that we're used to seeing based on the modulation and coding scheme index and spatial streams, he's actually gone through and calculated for all the different RU sizes that you can have. It's pretty mind-blowing. It's a huge chart, but very cool. Well done. So the guard interval, 3200 nanoseconds, we can get down to 800 nanoseconds. So if you remember from ADA to 11N and AC, we had 400 and 800 nanoseconds. So the reason why we've got these longer guard intervals is just to provide more resiliency and actually have better chance of actually achieving 1024 QAM over the air. So we've talked a little bit about contention. We all know this. We've all talked about this, right? Wi-Fi is a listen before talk protocol. It has to be very, very polite. So the legacy contention mechanism for Wi-Fi, that's where we reach those scale limits. That's where we have to back off so many different times. But we have to back off on very finite or very static thresholds that we've had in the 8 to 11 standard almost from day one. What do we have now? BSS coloring. This gives us greater spatial reuse and hence more efficiency over the air. And we can actually do a lot more dynamic working around our space in terms of channel overlap, not only for our own Wi-Fi networks, but a lot of the time, you've heard about Aaron talk this morning about external Wi-Fi networks causing havoc on your well-designed networks. This is where BSS coloring is really going to be a game changer for Wi-Fi 6. So if we consider 2 access points on channel 36, and we don't actually assign a color to these BSSs or these wireless LANs, it's just a number, but this is the way that it's good to sort of draw the analogy. So 2 access points, the same SSID, advertising on channel 36, and that's called a intra-BSS. So that's your own BSS, they're on the same channel, the same wireless LAN. They're technically going to talk over the top of each other, and if they're contending with the legacy contention mechanism, they're going to be fighting for the shared space of that transmission opportunity. What we have here is channel 44 and channel 44, but different BSS IDs. So they're probably different wireless LANs that are being advertised or different access points, or maybe one's on your infrastructure, one's not on your infrastructure. This is called inter-BSS. What does this mean? This is where it all wraps up. So previously, we've only had one contention mechanism with two different thresholds around energy detection and signal detection, and these have been almost static for the whole time that we've been working with Wi-Fi. There's been a few changes, a few different little tricks that different vendors can do to operate around this, but that's essentially how it's been. Now we have dynamic thresholds for both energy detect and signal detect for not only our own BSSs, but external BSSs as well. So this is where you have this concept of overlapping BSS versus my BSS. So your access point and your clients can then negotiate with each other and going, oh, well, I can actually hear my own access point on the same channel above a certain threshold. Are you going to give me the opportunity to talk over the top and assume that there's going to be a statistical chance of no collisions? All right, let's give it a go. And if it doesn't work, well, then you don't get any acknowledgements back and you try something else or you adjust the threshold. So this is going to be, we'll start to see this when vendors are implementing this in their code, and every vendor is going to do this in their own way and have some little secret sauce as to how they do that. But essentially, it's all about the efficiency as well. So not only is OFDMA trying to improve efficiency, BSS colouring is trying to improve our channel reuse in highly contested environments. Target wait time is the last one that I just wanted to spend a little bit of time on. Really what this is doing is also providing more negotiation between access points and clients to determine how frequently clients will wake up and listen to see if there's any traffic that's been buffered for them in the access point. Previously, most clients have been waking up on a function of the beacon interval, and that could be 1 beacon, 2 beacon, 3 beacon intervals, but it means that those radios are actually waking up more often than they really need to. So target wait time means that access points can then tell clients to sleep for a particular period, say, I'm not expecting to transmit to you for 2 hours, go to sleep. And the same thing can happen from the client's standpoint. You could have a telemetry device that's out there on an oil field saying to the access point, maybe it's a point to multi-point bridge that it's connected to as a workgroup bridge client, and it's just telling that access point, I'm not expecting to transmit to you for 2 days. And it could actually power its radio down and just save some battery there. So the aim of the game there is not only to make it efficient to transmit over the air. Every generation of Wi-Fi has efficiencies in terms of power consumption in the radio chipset, but this is really designed to not only help schedule these clients to actually wake up on a better schedule to save their battery, but the less that these clients are waking up and polling to see if there's actually any traffic there, that means there's a reduction in overhead over the air of all these clients waking up and doing power save polls, so that's pretty cool. Now, as we wrap up, how do you check Wi-Fi 6 on your network? Wi-Fi Explorer, you can see it in there. Packet captures as we've shown. If you've got a Samsung Galaxy S10, you'll see it on the device with a nice little Wi-Fi 6 symbol. Ekahau Sidekick will show it as well, because the beacons are backwards compatible for the other generations of Wi-Fi to cooperate with the contention. You can see that on the Ekahau Sidekick, and you'll be able to see it in your vendor's dashboard too, and just confirm that your device is actually operating with Wi-Fi 6. So, that was a whole lot of information in 30 minutes. I was trying to make up some time there for Francois to do his section, and then we'll have a little bit of a demo at the end. So thanks very much. There's a little reference slide there as well that you can get online, and hit me up later if you have any questions.
Sure. A lot of new acronyms. It's like we don't have enough already.
It's not learning about new tech, it's learning about new acronyms.
Yeah, exactly. All right, guys, thank you. I'm the last one for the day. I'm going to try to compete with the party boats with the topless ladies. So my name is Francois. I work for this company called SemFio Networks in Canada, and I'm here in Australia for the first time. And it's actually my first Wi-Fi design day as well. So I'm going to talk about Wi-Fi 6 design consideration and how it could change the way we design Wi-Fi today. So the WLS, or the Wireless Broadband Alliance, they did a survey this year, and they asked the question to a couple of companies, when do you plan to roll out Wi-Fi 6 in your network, right? So the results were, we already offer it now, right? 32% of companies answered that. 32% of companies said we're going to do it this year or next year, and then 20% 2021, 8% no plans, and then 6% 21, 22, right? So this is telling us that 60% of the companies surveyed will already have Wi-Fi 6 rollout today, right? This is probably not every company out there, because they surveyed service providers and like IT companies that are involved in it every day. But it gives you an idea that this might, come and affect us pretty soon in how we would design Wi-Fi on a regular basis. Okay, so what I tried to when I prepared this presentation, I was trying to think about what's in the new Wi-Fi 6 certification and in the new AX protocol. What features will come and impact the way we design today? If we go back to the typical Wi-Fi project lifecycle, I like to put it this way. So the first step is gather the requirements, right? Talk to the customer, understand what they want to do. Once you have all the requirements, you do your design. Once you have your design, you might do a couple of API on a stick to validate your design in a nice warehouse. Then once you have your design finalized, you can do the installation, the deployment, then you do the validation, and then the network is in production. You have the typical maintenance operation, and one day the requirements changes, and you have to redo the design or adjust the design and so on. So today I wanted to focus on the first step and the second step, right? So and try to look at what's going to change with Wi-Fi 6. If you look at the first step, gathering the requirements, I like to organize those requirements in 3 different sections. First one is everything related to the structural environment. So that's things like the floor plan, the scale, the ceiling height, ceiling structure, any AP mounting options we should have or limitations, area to cover, and so on. So this section is not really going to change that much with Wi-Fi 6. Whether we design for Wi-Fi 5 or Wi-Fi 6, it's not going to change much. Second big family of requirements, it's anything related to the Wi-Fi infrastructure. So the type of AP, type of antennas, number of SSIDs, minimum data rates. And this might change, especially type of AP. And the last section of requirements that are important are the clients and applications. So know the type of clients, know the type of applications, and you want to know that to do your RF design and your capacity planning. And in this section, we might have changes as well, especially in the type of devices and maybe the type of applications if Wi-Fi 6 is bringing new application or new type of clients onto our networks. So looking at the AP, I start to look at the different APs we have available on the market today. And if you look at the MIMO, they're either 4x4, 2x2, or 8x8, and you realize that some of them need a little bit more power, right? Especially the 8x8x8. Stephen talked about multi-user MIMO. Some vendors are really trying to take advantage of that, and they want to bring some 8x8x8 APs out on the market so they can leverage multi-user MIMO, but this means more power for the AP, right? And then if you look at the Aruba, this is the laser, right? If you look at the Aruba 555, which is a 4x4x4, but it requires more power, and this is because they have a whole bunch of other things embedded into the access point, IoT hubs, and a whole bunch of different things in there that will require a little bit more power, okay? So looking at that, we might have these new requirements in our network where the AP will need more power for 2 main reasons. First one is the 8 stream, and the second one is the AP will come and support more than just Wi-Fi, right? They become a platform for IoT as well, and you start to see that from different vendors, Cisco, Aruba. They're trying to have the AP being handling other IoT technology like Zigbee, Bluetooth, and so on, and they want the AP to be the hub for those applications as well, and that requires a little bit more power. So we might need BT, 802.3 BT, so more power, or some access point. What they do is they have 2 Ethernet ports on the AP, and you can do dual AT power to get enough power to support all of the features, okay? If we look at the client devices, I just took 3 typical Wi-Fi 6 client devices we have on the market. First one is the Galaxy S10. So second one is the iPhone Pro and the iPhone 11. And third one is the Intel chip that you can put in a laptop or a computer. If we look at the specs, they're 2x2x2. right? And the maximum transmit power, we have 19 dBm, 21 dBm, 22 dBm, right? So is that different from what we have today? Not really, right? We have most of our client devices are 1 or 2 spatial streams. It's typically the same type of maximum transmit power as well. So we don't have, for now, right? We don't have, different type of client devices. So that might not, affect our design that much. What might affect our design is maybe, we're going to have new type of client devices coming into the Wi-Fi, right? Like Stephen was saying, in AX, they're trying to develop some features, especially for IoT devices, right? So TWT, multi-user FDMA, support backed on 2.4, and that means that we might have more and more IoT devices coming into our network, Wi-Fi network, and that might change our requirements, right? And we might have to cater for them, right? And then our IoT devices might become our LCMI, least capable, most important device, and we have to adjust our design according to them. In terms of channel planning, we still have the same available spectrum, the same amount of spectrum available to us. That doesn't change, right? So we're still going to be designing for 20 or 40 megahertz wide channels for the most part. We might be able to go larger if one day we get spectrum in the 6 gigahertz frequency band, but that's not done yet. So for now, that's not really gonna change anything. The only thing that's going to change is we're going to use the spectrum we have in a more efficient way, right? So that might impact our capacity planning, but in terms of RF design, we're still going to be using 20 and 40 megahertz wide channels. For the SSIDs, so one challenge we have today is if you have the same SSID on the 2 frequency bands, you're relying on your client devices to take the right decision, right? You're relying on the green diamond, and some green diamonds are very dumb. They're always going to go on 2.4, and some devices don't support the advanced feature that we have with the 11K VR that we could leverage to improve that situation. So what we end up doing to overcome that issue, we design for one special SSID just for 2.4, another special SSID just for 5 gigahertz. So when a client connects on 5 gigahertz, stays on 5 gigahertz the whole time, and we kind of force the client to stay on 5 gigahertz and keep that good experience. What might change with Wi-Fi 6 is Wi-Fi gel multi-band is a requirement for Wi-Fi 6, just like WPA3. Mark talked about that this morning, so that's another nice thing for our client devices, because if you look at the Wi-Fi agile multiband requirements, you'll see that for any station, they'll have to support neighbor reports, which is one feature of 11K, BSS transition features, part of 11V, and then over-the-air fast transition, which is one feature of 11R, okay? And that means that our clients will become more intelligent. Woohoo. The green time and mat becomes more intelligent, and that means better, faster roaming, better steering. So we could go back in a scenario where we have the same SSID on 2 frequency band and rely on the client to take the good decision. One issue we have today with having 2 different SSID and 2 different bands is some devices that are only 2.4 compatible, like the Apple Watch. They will see what the phone is connected to, and if the phone is connected to the 5 gigahertz only SSID, the watch doesn't see it and just lose the connection because it gets the configuration from the iPhone, right? So maybe we'll be able to solve that problem with this. Now, if we talk about capacity, that's really the big challenge with the way we're going to design for Wi-Fi 6 for me. The way we do capacity planning today is we look at the airtime we have available to us, and we try to calculate how much airtime each device will be using, right? So based on how fast they talk, so based on their speed and based on how much data they need to send, we can calculate how much airtime they will be using. And then if we know how many client devices we have, we can estimate, how many radios we'll need to support all of our clients and all of the traffic they generate on the Wi-Fi. To do that, we can use, capacity planner from Revolution Wi-Fi. We can use Ekao as well. The issue now with Wi-Fi 6 is we have a lot of things that are changing and that will impact the way we actually calculate, the capacity on the Wi-Fi network. A couple of things I put here: multi-user OFDMA. So multi-user OFDMA, Steven talked about it. So we kind of know how it works and the different RUs, and we'll be able to talk to multiple clients at the same time. What we don't know is how the vendors will actually implement it. So how do they allocate the RUs, right? How does the AP decide to allocate 106 RUs versus smaller RU? We don't really know the secret sauce behind that, and that might affect the actual speed that you'll get, that the specific client will get, because the size of the RU will change, right? And so this will impact the capacity. Multi-user MIMO, I don't talk much about it. I'm still on the waiting and see if it's going to work. Scheduling transmission, TWT, right? This is too will impact capacity, because if we have a device that just wants to schedule one transmission a day, right? We don't really know about it. It's just going to schedule that with the AP, exchange a couple of packets, negotiate that transmission schedule, and you don't really know when you do your design how the different devices will negotiate that scheduling. So how do you import that into your capacity planning? That's another question. BSS scoring, same thing. How will the vendor implement it? All the time? Maybe it's just some of the time. How do you know when it will be used, right? Will they have different threshold for their RSSI level for the BSS scoring? And then 1024 QAM, where will 1024 QAM be used, right? Will it just be in a 2-meter radius around your AP, or will it be maybe bigger, smaller, depending on the client devices? Will it be used on 5 gigahertz, 2.4, only on 5? So all of these questions I don't have the answer to, but we need the answer if we want to calculate the actual capacity planning, right? And that's what makes it very challenging in the way we will be doing capacity planning in the future, right? So do we have any solutions? I'm not sure the vendors will share how they implement OFDMA, right? They're probably going to be part of the secret sauce and the way they compete against everyone else. And same thing with their scheduling. So if they don't share that information, we either have to guess or reverse engineer. A lot of moving pieces making the calculation more complex, right? Which modulation will be used? Because the way we do it today is we do the capacity planning based on the maximum speed that a specific client can do, right? But if we go back to Wi-Fi 6, the maximum speed that a Wi-Fi 6 client can do will be using 1024 QAM, and we know that we won't be using 1024 QAM across our entire environment, because we won't have enough SNR to achieve that modulation technique across our entire environment. So, what do? Do we do capacity planning based on 256 or something else, or do we establish some sort of percentage and say 10% of the time I have that modulation? So that becomes another challenge. A lot of moving pieces. BSS scoring is the same issue. And then some features might not be supported or enabled all the time, right? And that's for the AP side and the client side. You don't really know, right? And we kind of have the same issue right now with the spatial streams. We just assume that my phone is 2 spatial stream. It's just going to use 2 spatial stream all the time. But if you actually do some packet capture, you might not be using 2 spatial stream all the time. Maybe you have power saving mode on your phone, and then you just turn it down to 1 spatial streams. Or maybe your battery life is under 50%, and then it just turns it down to 1 spatial stream. So that's a lot of other things that we don't really control, and that will change from one device to another, one AP to another. That will make the capacity planning very complex. So I don't have a solution today. Maybe one day. Design tools. I'm relying on these guys to find solutions. So what I want, at least to be able to do predictive signal propagation, that should be okay, because we're not changing the antenna and the way we do signal propagation. Physics is still physics, so that should work. Prediction of co-channel interference level. Even better, maybe include some sort of BSS coloring algorithm there would be nice. Prediction of achievable data rates. That should be also doable. And then updated capacity planner. That's going to be the hard piece on how we can do that. And then the new tools need to be supporting these different things. 1024 QAM, so we can actually calculate the data rates we can get with 1024 QAM. Actually, Wi-Fi 6 is bringing a whole bunch of new data rates. All the data rates are changing because of changing the I forgot the subcarrier width. We're changing the symbol duration. We're changing the guard interval, and all of that impacts how we calculate data rates. So all of our data rates are changing. So at least the tools should be able to support all of this. BSS coloring, that would be nice also if we can have some sort of visualizing of the BSS coloring. And then multi-user OFDMA, try to incorporate that somehow. I don't know how, but like somehow try to see that. Maybe in the tools like Ekao, one day we'll be able to leverage that to get a little bit better understanding. At least get the prediction of achievable data rates based on the type of clients we have and the type of APs we have. Yeah, we decided to do a demo. So right, what could go wrong? So what we have for the demo is we have a Wi-Fi 6 AP, right? Actually, I have a little diagram. And when we prepared the presentation, Steven sent me his slide. And then I did a Control F for AI, because it's from MIST, right? And I didn't find anything. I was like, what? A MIST presentation without AI? So I put AI for him over there. So he wouldn't feel too bad. So we have a MIST AP to Wi-Fi 6 AP43. We have an SSID going on, the PSK, connected to the MIST cloud. And any of you guys have a Wi-Fi 6 phone? Yeah? Okay, so please connect to this SSID. This is the pre-shared key. And then what we'll do is we'll have the Psychic. I just need to turn it on. We have the Psychic to monitor the spectrum. And so we'll start by looking at that first. We'll give you the go, and then we'll start a speed test. So if you can just start your speed test application. We'll do a speed test and try to see if we can generate some OFDMA traffic. And then after that, what we'll do is I'll show you how we can do a packet capture, Wi-Fi 6 packet capture, and we'll try to analyze the packet capture as well. Try to see if we can see some of the trigger frames Steven was talking about. Okay? So let me go back in. Oh, my license expired. Yeah. Yeah. Okay, so the actual access point is on channel 52. So I'm just going to miss demo, right? So with the zoomed on channel 52. So I'm going to connect to. So how many people do we have connected to the Wi-Fi? Yeah, the password, sure. It's Mystify01.
Someone with Barry's iPhone 4 is connected. Who's that?
This is not a Wi-Fi 6 device. How many people do we have connected? 1, 2, 3, 4, 5.
I don't know, ask Steven, he's got the
Yeah.
cloud.
Steven?
16 AX.
Okay, all right, let's try that then. Let's go back to. You guys ready? Are you guys ready to start a speed test on your phone? No? Yes? Okay, thank you. Okay, 3, 2, 1, go. Yeah. Whoa, so we saw some, I think we saw some of the MM, now it's, that's pretty cool.
Maybe everyone needs to come closer to the sidekick.
Yeah, I'm getting 1 meg. Oh yeah. Yeah, no, it's fun. Are you done?
Yeah, I'm done.
Yeah, it looks cool, huh? It looks different than typical OFDM. Then how can we be sure that this is OFDMA? Who says dumb? Packet never lies, right? So let's do a packet capture and then we'll redo a second test and we'll try to see if we're actually generating some OFDMA, okay? So to do AX packet capture, you need an AX card, right? So what we have here is we have a small computer. It's called a Jetson Nano. It actually has the module, so you can connect AX card. It's a M2 connector. And I put the Intel AX chipset in there, connected some antenna to it, and it's running Linux. And it's actually connected to my computer via Ethernet. And what I can do is I can SSH into it. I can configure the card to be set in monitor mode on the channels we care about. And then from our chart using SSH plugin, I can start the packet capture and then send the packets back to my laptop. Okay? Do some sort of remote packet capture. So I'll show you how that works. I'll close this one first. Can you guys see this? It doesn't have an AX card.
We'll just merge the two together.
Are you coming with Psychic V2 with the AX card? I'll take it.
No, that's after he sold everyone. I've got to upgrade.
Alright, so I SSH into the Jetson Nano, right? And then here, I created an alias that will just pretty much set the WLAN 0 card into monitor mode on channel 52. So that's the one we have. So I can just press start. That's my password. Do it again. Oh. Let me see if it'll work. Yep, so it works. So now I have my monitor interface in monitor mode on channel 52. Okay? Once this is ready, I can go back Wireshark. Wireshark, I've installed this SSH remote packet capture plugin, and here I can specify the IP address of my Jetson Nano, the port I'm using, SSH here, and then you have to put your credentials, and then you have to specify the command that you will execute. So for me, it's just a TCP dump I'm doing on that specific monitor interface, and then I can start it, and if everything works well, we should start seeing packets. Right, and because I'm doing packet capture with that AX card, we can actually get some AX data packets, right? So on top of the management, sorry? Where do you see that? Oh, clear to send, yeah. Yeah, it's alive. It's advertised all the time by all Wi-Fi clients for us. We don't have to do any advertising. Yeah, so here you can see the blue frames are the data frames. And you can see here in this column, the PPDU, if you see HE something, HESU, this means this is the HE, so high efficiency single user communication frame. So this is actually an AX frame, right? What we can try to do now is try to redo our little test, okay? So I'm gonna ask everyone that's still connected to the Wi-Fi 6 to start their speed test again. 3, 2, 1, go. Oh, you started already. That's why I have 1 meg. Yeah, I'm not even on. Are you guys getting anything? You get 20? I got 1.5. Oh, upload is better, yeah. Alright, so I'm going to stop that. And so here, if I take this one, for instance, or this one here, right? You can see I have a column for HEMCS, right? So here I can actually find out, and this is from the radio tab header, right? And the radio tab header is updated with HE, so with AX. And the radio tab header you get from the Intel AX card is really good. It's better than the one you'll get, especially on Linux. It's better than the one you'll get from, for example, if you do a packet capture from an AP, right, XAP. So if I take this frame, for instance, do you guys see, or do I need to zoom in? I just need to zoom in. Huh? All right, I'll take this guy here. And if I looked at the radio tab header, you'll be able to see this HE information, right? And then here in the HE information, you can see that it's a HESU, right? So here we're not doing multi-user; it's a single user transmission, and you'll be able to see that information. So here it's a bandwidth RU allocation 20. So this is telling us that it's using the full 20 megahertz wide channels for that communications. If you have multi-user communication, you'll be able to see, you know, the RU size in here as well, and I can see the guard interval, right? I can see the number of spatial streams I have here, the signal obviously, and the MCS is right here. I don't see it now. Do you see it? No, this is just a flag. Oh yeah. No. Yeah, I need to, yeah, exactly. Yeah. HE data. Yeah, I can try to say that. But I didn't see any coming out. So here, if I want to find out if we did some sort of multi-user communications or OFDMA, I can filter with this type of frame, and this type of frame is the trigger frames that we use for multi-user communications. So here it's filtering through the packets. So we have a couple of them, right? And if I take my trigger frame here, and I look into it, you'll have this user info information element, and here you can see the details about the different users who are sharing the channels, right? So here we have 2 users. You can actually see their AID, association ID, right? Association ID is an ID you get when you associate to the BSS. We didn't really care about that too much until now, but that was necessary for the operation of the BSS. Now we're going to start caring more about them because you'll be able to see which client is using is actually sharing that multi-user communication, right? One thing that's going to be challenging if you want to do the correspondence between the AID and the MAC address, you have to capture the association. Okay, so that's going to be challenging for us to do some troubleshooting. Yeah, and so here I can see the allocation, and then if I go in, up user information, you're able to see the tone, right? So the size of the R here. Do you want to see something else?
Yeah.
For the trigger frames?
The broadcast.
Yeah. Yeah. So your AP probably has 6, right? Enable as a minimum data rate, so it's probably using that. Yeah, it will use 12. So yeah, use this one.
Let's try this one instead. Hello? 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 Hello?
Yeah.
Hello?
Don't talk.
I just wanted to say about target RSSI and how the access points can tell the clients to turn the transmit power down, as well as the clients can request for the access point to transmit at a certain transmit power. So it goes target MCS. This is the target for what the AP wants to hear. Yeah. So the MCS, the spatial streams, and the tones will determine what the MCS rate is that the access points expect. Hello? Awesome. Okay. Target RSSI. That's when you've got the access point sending out these trigger frames to clients for uplink multi-user communications. And basically what that is dictating is you've got this target RSSI of negative 30 dBm, up to 2 spatial streams used for 106 tones. And you can see there the MCS hasn't been decoded properly, but that MCS will then say, okay, for that transmission from this client, the access point is expecting to get this MCS rate back. So that could be MCS 10, it could be MCS 11, but all of this information factors into it. And so if that target RSSI is not met, it means that the signal to noise ratio is not good, the environment's too noisy, and the next time you'd see a trigger frame for the same user, you'd probably see that target RSSI has dropped down. And then it's probably choosing either less spatial streams or it's aiming for a lower target MCS rate.
Just one thing I want to see, if I remove the filter, yes, no, that's still, here I can do, can I solve with that? I want to see if we got any multi-user, HE multi-user. It's still dissecting my packets. Yeah, probably.
You only had a couple million.
I have, what I have, 615,000. Yeah. it has to go through the packets.
Someone
again.
threw a rock at the screen.
So it's not. Yeah. Anyway, at least we got to see some traffic on the spectrum. Look at that. Wi-Fi 6 traffic on the spectrum. I get to show you the packet capture. I actually have a blog on my website that tells you exactly how to do the whole thing. You just have to buy the equipment. That's on you. But you can replicate that
So
at home.
that's about less than $200 US, right? All up? It was a bit more than that.
Yeah, I would say 250 if you buy the whole package with the case and the antennas took the longest for me. I don't know why, but you could probably find. Yeah, the external. You didn't just steal them off an IP at university. No, yeah, you could do that if you want to, or you could do it without. You just won't get the same results, right? But yeah, you can build it for yourself, and replicate the same, right? So it's pretty cool. You'll get better results like this. You could install the same Intel chipset in your laptop and do it from applications. Thermograph. What's the name of the Thermosoft? ComView for Wi-Fi. You can do it. But when we compared the radio tap header, it wasn't as good as what this guy is giving you, right? So on Linux, with the Linux driver, it appears to give you more information. You can set up this solution, and then you can do remote packet captures with that, so it's pretty nice. Thank you. You want a sidekick as well. To look at this, yeah. Okay. Well, thank you for your attention. Hopefully you learned a couple of things, and then we'll be here if you have more questions. Thank you.
Yeah, I've got a mic. Can't believe someone gave me a mic.
Okay. Wow. That was it. That was the last one, Grant.
Just a note on the Jetson Nano there. I've got one at home as well. It cost me around 200 Australian, but I don't have as fancy case or power button or anything like that. The power supply is expensive too, but you can power it off USB, so it's not ideal, but not as mobile. But so you can sort of do that if you want. There's some good blogs around that, so check out the Francois' blog. So I think we've got a couple of giveaways.
Yeah, we got to give some gifts away. First of all, okay, do we still have all the speakers here? I think they're still around, right? Okay, so we haven't had time for question and answers, so we're going to get you guys to ask some questions now. So the speakers are all around.
I don't think we've got time for questions.
We got time, mate. We got time. So if you ask a question, don't be shy. We'll give you a hat. And these are the Ikehau limited edition hats. So I got a bunch here. No. You've already got a lot.
If anyone needs any Ikehau merch, just talk to Aaron. He's got everything. No joke, we got some stuff shipped from Finland to us. First time we'd seen it, and Aaron's like, "Oh yeah, they're really nice." Like he's got it all. He's got it all. So go and talk to him.
He's got more than I do, I think.
Yeah. So.
Questions? Can we do questions?
We don't really have the time. We got to be done in 10. We got to be done in 10 minutes.
Okay, quick questions.
Really. No. No questions.
Yes or no questions only.
So.
Yes.
Francois was trying to show us data packets from my capture. What were we actually expecting to see there?
No.
This is why we don't do questions.
Yeah.
So we are. What I would say is we are going to have drinks here. So we're sort of around the other side. So literally the way you walked in, if you walk back around from 3 till 5, we are going to have drinks. The speakers are going to be there. Ask Francois. Yeah. Yeah. Did you want to?
Do I get the hat if I answer the question?
I was just asking the data packet that you were actually running.
Yeah.
Display. What was the key feature?
You're going to be able to see that it's a multi-user PPDU. So it's actually a multi-user frame. right? Okay, so the AP will send it, and then it will go to multiple users. Yeah, and you'll be able to see to who it's going to based on the AID in Wireshark. Yeah, yeah. I'll try to post. I have a picture of it. I'll try to post it on Twitter so you can see what it looks like. There's this guy based out of Norway, Garmont Rain. He actually did a blog post on it, and so you can go on his blog as well and see what we're trying to achieve. Because here we got some trigger frames, so we knew some OFDMA action was taking on, but we didn't see any multi-user data packet communications, right? Trigger frame is not a data frame. So that's what I was trying to show you guys. Yeah. Hat? Answer your question. Thank you.
I can't believe you don't have a hat. I'm surprised you don't have
Good
a hat.
answer. Yeah, good answer. That's worth a hat.
All right. So we did have the ECSE.
Okay.
Right.
Okay.
So Darko, do you want to come up?
So this is one from Twitter, one from LinkedIn, and you're going to you've chosen already, or
I've already chosen,
Oh,
and
you've
the best
chosen,
ones are
okay.
on Twitter.
okay.
So the LinkedIn ones were
Oh,
pretty. So
you rejected the LinkedIn ones.
no, I checked LinkedIn,
Okay,
but
okay.
the Twitter ones were really good. So
Sure. What am I announcing? And the winner is
because there's been a lot of posts, so I took some pictures, some screenshots. So one of them was Luke Bouldery.
Luke. Where are you, Luke? Come up here. Well done. Congratulations. That's for you. That's a $2,000 voucher towards ECSC troubleshooting course.
Ooh.
See you there in April. Awesome. Thank you. And that's his post.
This was the post. This was the post. So I think everyone should have a look.
Yo-yo tricks. Okay.
Where's the other one? So the other one was Cedric. So it wasn't just this one, but there's been a bunch throughout the day that have been really good. And we've got an artist in our midst, Quinton Beggs. Don't tell me he's left early. Hey, come up here. So let's see if I can find it, because it was earlier in the day. And when I say artist, you'll see, there it is. Look at that. So, I mean, right? So, so very, very well done. Now, and now we've got the bags. So,
We'll throw a couple of hats in there, shall we?
Yeah, no, we're going to do it.
Oh, how are you doing?
Get a few out.
yeah.
Do a random
Yeah,
draw thing,
yeah.
right?
Yeah, so there's been a couple of people posting throughout the day. So I'm going to just see if we can bring them up, and they're going to do a bit of a lucky dip. And
okay.
so some of them it's got bags, some of them you don't get anything at all. I'm just kidding, we'll give you something. And then other is hats. So Matt, yours has been very entertaining, especially the nerds one. That was fantastic. So please come up. John Badham, Rasika, and Will.
You're just scrolling and picking names, mate. What is this?
Hey, hey.
Post now,
LinkedIn,
you might get
LinkedIn.
one.
I had a look at LinkedIn. It was pretty.
Choose a couple from LinkedIn, you slacker. Come on, mate. They're looking for jobs, yeah.
All right, Craig Ells. No.
I posted on LinkedIn as well.
Anthony Prasad.
Yeah,
No, you can't win anything. Jeff Road. Jeff Road. No. Cheating. Oh, well, you have to actually be up on stage to win anything. How many have we got at the moment?
He must be on the
five.
live stream, mate.
We've got 5. Evan Wood was another one.
Are you sure we've got enough prizes to give away?
If not, I'll give you Anthony's credit card details. Just go and buy yourself something nice.
We've
That was
got,
3 weeks ago. We can't give them to someone in the UK. That's a good one. Jalen. Oh, not Grant Shelley, not me. Jalen Ong. If you're still here, yeah, come up. All right. I think that's it.
That's it. How many?
Yeah, we've got a few.
Okay, lucky dip time, guys. Okay, shuffle the cards. I'm in.
We rehearsed this
No,
quite
just-
a lot.
Yeah. This is what we spent all day yesterday doing.
Pick a card.
Are you gonna make him
Yep.
disappear?
Got a
You
hat.
want black or white?
Black or white?
Tough choice, mate.
You probably got one of
Tough
each anyway,
choice.
right? Oh, really? All right. Well, the cool bag's got our logo on it, so that is a cool bag. That is a cool bag. You got a cool bag as well. Wow, they went quick.
The
They went
bags
quick.
are
Cool
gone.
bag. All right. No, you can keep that as well. It's a
Souvenir.
memento. Got a hat.
You want a black or white? Oh,
Alright.
it's going running out of black.
Right. And we got hat.
White?
Ah,
Go for it.
Take white. Okay.
We've got XXXL. Alright, good.
Yeah, we got.
we got one more.
Didn't
The
where's the
Rasikas down here.
jackets, mate?
What the? Told you we rehearsed this a lot.
You want white hat? Okay. This
Or
jacket
do you want the
won't
hoodie?
fit him. This is
Yeah?
like triple
Okay.
XL, mate.
All right. Okay, I think we got to be out by 3, so I think that's it.
That can't be it. What are you talking about? I was gonna do a demo and put some prices up and give some discounts.
Yeah.
No, so okay. Thank you all for coming, and special thanks to the speakers. You guys did a great job today, and this is the community that we want to build. So hopefully we'll do some, get to know each other. We're all in the Wi-Fi space, and this day wouldn't be possible without all of you guys. Special thanks to the sponsor, Darko. You're the man, and join us for drinks. Yeah, we're
The
finishing
sponsor.
early, and I hope you guys enjoyed yourselves. Yeah. Okay.
Yep. All right. Thanks,
Thanks, guys.